Clementina Limited, manufacturers of Clemco sandblast equipment, welcomes you to the ABCs of surface preparation. This course is designed for those of you who do not sandblast at present, but should, and as a valuable refresher course for those of you who do. Catching a ride on a San Francisco cable car for the first time is quite an experience. One might feel that San Franciscans prefer the sentiment and tradition of the past, until you view their progressive freeway systems and their modern airport, which jets them to the four corners of the world. A strange contrast between the good old days and modern day. Can your business afford to retain an outdated method, even though it is a minor phase of the total operation? The principal progress in tool development is toward labor-saving features. As labor costs have risen, tools have been developed to make each man-hour more productive. This same development has taken place in methods of surface preparation. Of course, there are other ways of preparing a surface. If you are still using any of these, it would be well to investigate the advantages sandblasting can offer. A progressive business depends on progressive people. So if any of you are not interested in progress, now is the time to leave. Why sandblast a surface? Let's begin by turning to the opposite sex. The reasons why a surface should be sandblasted are somewhat similar to those our girl gives for spending so much time on her face before a big date. Facial creams thoroughly remove her makeup, keep her skin in good condition, and provide a clean base for application of fresh makeup. She knows the value of good surface preparation. Sandblasting provides the best surface preparation. It not only cleans more thoroughly, but provides, through anchor pattern, the best surface for any coating. Anchor pattern is the etched surface or tooth produced by the abrasive striking the surface. The cost of modern coatings and labor demand the thorough cleaning and anchor pattern which only sandblasting provides, your guarantee of lower maintenance costs over the years. These are the essential components of a successful sandblast operation. For outside blasting, portable air compressors are used. These are gas or diesel driven. In-plant blasting is normally done with stationary, electrically driven compressors. The smallest sandblast machine can operate at 20 CFM, which is cubic feet of air per minute. But most blasting is done with 125 CFM or larger compressors. The air hose which connects the compressor to the sandblast machine should be at least 3/4 of an inch inside diameter, but preferably 1 inch or larger. The sandblast machine is a pressure vessel designed and coded to meet all state safety laws. In operation, this pressure vessel contains air and abrasive, and while blasting, there are no moving parts. Important design features for easy, efficient use of a sandblast machine are these: a concave head for easy filling, no need to fill through a funnel, an automatic filling valve, which seals when the air is turned on and opens when the air is turned off. Not an awkward filling cap. Piping at least 1 inch in size, a vital requirement for full airflow. Some units have piping with inside diameters of only 1/2 inch. This will reduce their blasting speed by 50%. High production sandblast machines are gravity fed through a cone-shaped bottom. Round bottom machines do not permit full and even flow of the abrasive. A handhole should be provided for quick removal of unwanted objects. Machines without a hand hole must be turned upside down in order to dump out the unwanted objects. The heart of a sandblasting machine is the abrasive metering valve. It should be quickly and easily adjustable to accurately measure the exact and steady flow so necessary for a proper job. Many valves have fixed openings. These orifice plates wear rapidly, with the result that excessive amounts of abrasive are used. A quick clean-out cap requiring no tools is provided for fast removal of objects that might plug the valve. Many units require complete dismantling, causing long periods of shutdown. Only sandblast hose should be used to move abrasive from the machine to the nozzle. This hose should be at least 3/4 of an inch inside diameter, and preferably 1 inch or larger to ensure adequate flow. Most important, it is designed to prevent dangerous static buildup. If air or water hose is used, static electricity builds up and can give the blaster a dangerous shock. Never use internally fitted couplings, which cause restriction, turbulence, and wear. Nozzles are designed to meet a wide variety of needs. They should be carefully selected for each job. There are 5 important factors in nozzle selection: compressor output, internal lining material, internal shape, nozzle length, and internal diameter. The orifice of the nozzle must be matched to your compressor output. Charts will be given to you containing this information. Do you remember the annoyance of writing with the old-time post office pens? They wrote unevenly and wore quickly. Compare that to the pleasure of writing with the quality ballpoint pens of today. Ballpoints write with an even, uniform pattern throughout a long life. Old-style nozzles of ceramic or cast iron were like old pens, fast-wearing and uneven. Using these, a blaster had little or no control over his work because the quick wearing of the orifice changed his conditions on air and abrasive supply, causing fluctuations in nozzle pressure and blast pattern. Modern nozzles are like modern ballpoints, long-wearing and even. They are lined with either tungsten carbide or boron carbide and will give hundreds of hours of service with minimal wear. Using a modern nozzle with long orifice life, a blaster is assured his air and abrasive supply will remain constant over long periods of use. The straight bore nozzle is a low-velocity nozzle, and this antiquated shape is seldom used today. The modern Venturi-shaped nozzle gives a wider, more uniform blast pattern with faster cleaning due to increased abrasive velocity. As in choosing paintbrushes, there is a proper size for each job. Generally, a short nozzle, say 3 inches long, is used where the object is small or where the cleaning job is not too difficult, such as raised and flaking paint. On hard-to-clean surfaces, such as rusted and pitted steel, bitumastic coatings, or where very tight mill scale exists, only a long Venturi-shaped nozzle should be used. In the old days, it required 2 men for each sandblast machine, one serving as the blaster and the other as the pot tender, who manually would start and stop the machine on signal from the blaster. Only if he sees the signal. Modern operators use only 1 man to a sandblast machine, and where many machines are being used, can employ 1 pot tender to service several machines. This is made possible by the addition of air-operated remote control valves, which allow the blaster to start and stop the machine right at the nozzle. These valves provide complete safety to the blaster. In addition to their safety features, they also will save on abrasives, as the machine can be instantly stopped once the blaster has finished the area he is doing. The dead man feature ensures instant shutoff should the hose be dropped while blasting, and protects the blaster from physical injury and the property around him from damage. This violent whipping can be deadly. These remote control valves can and should be installed on all sandblast machines. You should not sandblast on metal in rainy weather, nor should you blast with moist air entering the nozzle from an inefficient compressor. Dry sand flows quickly and smoothly. With just a little water present, flow is impossible. To eliminate moist air problems, a moisture separator of sufficient capacity should be installed on the sandblast machine. The moisture separator automatically eliminates the water accumulated by the air compressor. As a result, there is no interruption of abrasive flow and no moisture discharged through the nozzle, a necessity in high humidity areas. At the end of the day, the sandblast machine should be emptied of all abrasive and covered to prevent condensation from collecting in the pot. Care should be taken to prevent debris from being deposited in the sandblast machine. There aren't many nozzles made that will accommodate a cigar butt. A screen should be used to guarantee only abrasive entering the pot. This eliminates unwanted downtime. Dust from a blasting operation sometimes becomes a problem. The best way to minimize it is to introduce a spray of atomized water at the nozzle by attaching a wet blast head. This head, attached to an ordinary water hose, provides atomized water that surrounds the blasting pattern. This provides greater productivity as visibility is improved with no loss of air and abrasive speed. The water captures the dust particles and prevents them from spreading into the surrounding area, a great advantage when cleaning buildings in downtown or residential areas. Realizing how important pressure is, the money-making sandblast contractor doesn't guess at his nozzle blasting pressure. He knows what it is by using a hypodermic needle gauge. The gauge is the only tool which shows actual nozzle pressure. This inexpensive gauge should be a must on all jobs. Insert the needle into the sandblast hose as close as possible to the nozzle while blasting is being done, and get your true pressure reading. Rely on it, not the compressor gauge. If the hypodermic needle gauge doesn't indicate the proper high pressure readings, the operator should inspect his equipment to find the reason for his low readings. Sandblast machines are made in a variety of sizes, but all do essentially the same job. The choice of machine size lies mainly in the amount of sandblasting that will be done during a given day. The sandblast machine chosen should be large enough to avoid downtime caused by frequent refilling. We have used sand as the term for abrasives, but sand is only one of many abrasive materials. Today, one of the most common expendable abrasives would be a mineral slag product. Manufactured metallic abrasives and agricultural abrasives are also available. Only those materials specifically processed as blasting abrasives should be used. So far, we have considered only the mechanical aspects of sandblasting operations. The most important factor is the human element, the men performing the job. They can make or break your job. Make that critical difference between low profit, high profit, or even loss. For these people to do a productive and profitable job, they must be trained. Your men should know equipment and abrasives, plus the actual technique. To illustrate this technique, Let's watch an efficient crew run through a typical startup procedure and observe the important points. This setup is close to ideal for a small sandblasting contractor. It has all necessary equipment conveniently situated on the truck, including the sandblast machine, the various hoses, and the proper abrasive supply. Spare parts are neatly and conveniently stored so that there is little delay if a gasket is missing or a helmet view window needs replacing. Extra nozzles are carried so the proper one for the job can be selected. The crew first starts the compressor and allows it to warm up while the other equipment is being set up on location. When the compressor has reached its operating temperature, they check the pressure gauge to make sure the machine is adjusted to full operating pressure, 115 to 120 pounds per square inch. Be sure your men know how to adjust the pressure regulator on the compressor. They attach a large air line to the compressor's bull line outlet. They don't use the small manifold outlet. They use an effective moisture separator attached to the sandblast machine. They blow out all lines as well as the machine itself to completely avoid moisture problems. The machine is filled with the abrasive. No tools required when quick couplings are used on sandblast hose. The operator keeps his sandblast hose as short as possible and runs it straight to the work, avoiding sharp bends which cause excessive wear. The blaster uses a nozzle designed for the job and matched to his compressor output. He takes care in adjusting his protective air-fed hood. He knows a proper fit will ensure more comfort and greater visibility. Some state laws and most progressive employers require use of a helmet air purifier and use a remote control system for safety and economy. The operator sets the metering valve to ensure a minimum but adequate flow of abrasive to the nozzle. He knows it will save tons of abrasive and guarantee maximum production. He uses a hypodermic pressure gauge to make sure he has the high nozzle pressure which guarantees the highest possible cleaning rate. When blasting on steel, it is desirable to have nozzle pressures at 90 to 100 pounds per square inch. He holds the nozzle properly, 80 to 90 degrees to the surface for better visibility, and makes smooth, definite passes for greater production and less fatigue. One of the vital elements in training is the recognition of the surface cleanliness required. Every effort should be made to instruct the blaster that overcleaning is expensive, and undercleaning means you have to go back and do it over again. We have covered some typical sandblast setups which are commonly used in general cleaning or surface preparation. There are many surface preparation jobs which require special tools. As a point of interest and information, we will briefly cover these special applications. Tools which blast clean the complete 360-degree internal surface of tubing or pipe are available. These tools can be used with any conventional sandblast setup as previously shown. They are able to clean pipe that is stationary or stacked, since rotation of the pipe is unnecessary. The three basic models, with a combination of positioning collars or carriages, can internally clean pipe or tubing from as small as 3/4 of an inch internal diameter to as large as 36 inches ID. Sandblast cabinets or walk-in rooms are available for the most minute parts or the largest completed assemblies. These units, equipped with dust collectors, reuse the abrasive and eliminate dust and contaminants. They are widely used in shops, industrial plants, and manufacturing plants. Many are designed and constructed to order and are often equipped with turntables or conveyors for production line work. The Eductomatic is a small, lightweight vacuum pickup blaster and well suited for cleaning welds, rivet heads, or general touch-up work. Its small size and swivel head allow it to be used in confined and hard-to-reach areas. The vacuum pickup recovers and recycles the abrasive for reuse and eliminates dust, making this tool ideal for work in machinery areas. A suction gun machine is well suited to light-duty blasting, such as frosting glass, minor paint removal, wood finishing, and similar applications. Small pressure type machines, which incorporate all the features of high production units, are especially effective on tough cleaning jobs where size is a limiting factor. They are, in effect, high production machines in miniature. These machines should be coated vessels which meet all safety requirements. This concludes our introductory course in the ABCs of surface preparation. We know we've given you a lot to absorb, and for this reason, much of what you've seen in this film today has been incorporated into a pocket-sized booklet. It's yours with our compliments for review and reference. Thank you for attending our class.